Good afternoon, everyone. My name is Fadil Shamnand Rabeka Jalal, and I'm a student at University of West London. Today, I'm going to show you how I created the Cute Icon app, an interactive app that lets users click on cute animal images and display dynamic feedback. Let's dive deep into the code and break down how it works. Here's the layout for the app. We use a linear layout as a root with a vertical orientation to stack everything neatly. Inside, we have three horizontal linear layout sessions. The first and the third session each contains two image view elements, one for a cute dog, the other for a cute cat. In the second session, similarly, a rabbit and a bird in the second. Each image view has add layout weight is equal to 1 to ensure they evenly share space. The scaly type is equal to center inside. Code keeps the image proportional, while layout margin gives us some breathing room. Each image has a content description for the accessibility purpose, ensuring that the app is usable for everyone. Let's move on the code where the action happens. In the handle image click method, when a user clicks on an image, we update the text in the text view to show which image was clicked. If they click on the dog, for example, it will show you clicked on a cute dog. The text is updated to blue and the clear text button is made visible. Depending on which image is clicked, we change the background color of the clear text button to match the animal. For example, the dog's button becomes brown, the cat is gray, and so on. Now let's look at the clear text button. Now let's look at the clear text button. When clicked, it resets the text in the text view to its original message. Click on any icon. It also hides the button again to keep the UI clean for the next interaction. As you can see, when the button is clicked, the text resets and the button disappears. This helps the app feel fresh after interaction. To enhance the user experience, I added a simple animation where image is clicked, it enlarges and then returns to its original size. This is handled by the apply scale animation method. Here's image scale to 1.2 times its size and then shrinks back, giving instant feedback that the image has been selected. This animation lasts for 3300 milliseconds and adds a fun visual touch to the app. Inside main activity, I set up listeners for each image view. When a user clicks an image, the handle image click method is called with the name of the animal as a parameter. Similarly, the clear text button has its own listeners, triggering the clear text method to reset the app state when clicked. Now let's see how it all works in the app. When I click on any of the images, the text updates with the animal name and the clear text button becomes visible. Clicking the button resets the text and hides the button again, giving the app a fresh start. Thank you. Next, I'll walk you through a pizza ordering app where users can customize pizza, select toppings, and see real time updates. Let's start by exploring the app and the code behind it. When the app opens, user sees a welcoming message and a pizza image. Below that, it's a list of toppings, each with a price. The layout is built using a linear layout for a vertical stacking wrapped in a scroll view for smooth scrolling. In the backend code, we have a base pizza price set to 6 euros. When the user selects a topping, the update order method adds its price to the total. For example, selecting tomatoes adds 2 euros to the base price. The total price is updated dynamically on the screen. To make the interface engaging, we add animations in the setup checkbox with animation method. Whenever a checkbox is selected, it briefly enlarges, giving immediate feedback. This enhances the user experience. Each selected topic is also represented visually. In update order, we dynamically created image view for each toppings like tomatoes or mushrooms and adds it to a corner container below the pizza. These icons appears with smooth animation for a polished look. When the user clicks order, it does display the total price. If no toppings are selected, the app prompts the users to choose some before ordering. This logic is handled in the orders button and the set or click listeners. To reset the order, the clear button calls clear order. This method unchecks all toppings, removes icons, resets the total to 6 euros, ensuring a clean slate for a new order. This app combines essential Android components like checkbox, text views, and linear layout with simple animation to make pizza ordering fun and interactive. To sum up, the app is intuitive and dynamic. Users can easily select toppings, see their total price in real time, and place or clean their order. Thank you for watching and hope you enjoyed this brief look into both the app and its code. Thank you. Next, I'll be presenting my Destination Catalog app. This app lets users explore iconic locations like the Burj Khalifa, Dubai Creek Harbour, the Dubai Expo, and the Global Village. Let me walk you through the code that powers it. Starting with the XML layout, I've designed a clear and user-friendly interface. The main structure is a linear layout with vertical orientation. At the top, there is a text view for the title, followed by an image view to display the destination image, and another text view for the description. Below that, there are previous and next buttons for the navigation. And at the bottom, I added a dynamic thumbnail navigation bar with image buttons for a quick access. Moving to the main activity.java, I've created an array list to store the destination. Each destination contains a title, description, and image resource ID. The description are initialized in the setup destination method and the display destination method. Dynamically updates the title, image, and the description on the screen based on the selected destination. The, the navigation button uses click listeners to cycle through the list. The previous button decrements the index to go back, while the next button increments the index to move forward. The bottom navigation bar is populated dynamically using the image button, allowing users to jump to any destination instantly. Now, let's talk about the destination Java class. This class serves as a data model for each destination. It has three fields: title, description, and image resource ID. The constructor initializes the values, and there are greater methods to access them. By using this class, the data structure becomes reusable and easy to manage. Finally, here's this app in action. As it navigates using the bottom, you can see the title, image, and the description changes seamlessly. The bottom navigation also allows me to jump directly to any destination. That's a quick overview of the Destination Catalog app. Next, let's go through the login and register app. Our app begins with a simple interactive layout defined in the activity main.xml file. This layout includes a login button to take users to the login screen and register button for a new user to create an account. The logging activity.java. Now let's move to the logging activity.java. This is where user logging with their credentials. Upon entering a username and password, they click logging. First, we validate that both fields are filled. If either it's missing, we prompt the users to fill in the details. If the credentials match or hard-coded values for this demo, this user is redirected to the home screen like this. And the activity login.xml. Here's the activity login.xml file that defines the layout for the login screen. It contains field for the username and password along with the login and register button. Register activity.java. Next, we have the register activity.java. This is where new users can create an account. They enter a username, password, and confirm the password. The app checks if the password matches, and if all fields are completed, when the user clicks register, the details are stored in the database. Activity register.xml. The activity register.xml defines the registration form layout. It includes fields for the username, password, and confirm password as well as the register button. Database helper.java. To store user credentials, we use database helper.java. This is where we define our SQLite database. Create tables for storing user information and manage data insertion and retrieval. When a user registers, the credentials are stored in the database. The app checks these credentials during the logging process to ensure users can access their accounts securely. Android manifest.xml or Android manifest.xml file handles app configuration. It declares the app's activities, including logging activity, register activity, and welcome activity. It also defines permission required for the app, like internet access or for future updates. Welcome activity.java. After a successful logging or registration, users are taken to the welcome activity.java. They greeted with a personalized message. It's a nice touch to make the user's experience more engaging. Let's see everything comes together in action. When the app starts, users can either log in or register a new account. After successful registration, they can log in and proceed to the welcome activity, where a personalized greeting awaits. And that's the flow of our app. With simple layouts, easy navigation, and secure user authentication, we ensure a smooth experience from start to finish. Thank you for watching.